Section 1 is what we call basically the basics of geometry. Everything that we talk about throughout the entire school year is going to come back to something from this section, essentially, right? In order to make a line, we have to have specific geometric parts. In order to make a segment, in order to make a plane, or any type of figure, it's made up of a lot of different parts of the basic geometric figures. So we're going to start with the very first basic point. It's a location with no size or shape. So then we're going to talk about how to picture it and then obviously how to name it, because that's going to be a really big part of geometry is how do we name something. And there's going to be a lot of different symbols that we use, a lot of different things that we use to help us with that. Okay, so to start off with, I think of like a star in the sky, right? There's tons of stars in the sky. And if I say, okay, but that's one specific star, one specific point, we got to identify its location. Each different star is in a unique location in the sky. Points are the same way. I can put point A anywhere on a flat surface. I can put it up here on this board somewhere. And then when we name it, we're going to name it point A. And we're going to use a capital letter to name it. I can use any letter in the alphabet. So, some of you might say, well, why don't we use P for point? You could do that. You could label it point P. Yeah?
What happens if you end up having more than 26 points?
Won't happen very often. So that's a good question. If you did, at some point we'll put like special labels on it to call it something else. Or you could use like a double A or double B and use two letters. But that won't happen very often. Okay, a line. So thinking back to Algebra 1, okay, we made a line. And when we did that, thinking about like graphing on a coordinate plane, we put 2 points up here. We connected those 2 points together. We made a line. And we put an arrow on either end to show that it's going to continue on forever. It's never going to stop, right? So that line extends forever to infinity. And so when we draw a line up here, okay, and the points that you use don't matter, okay? So I don't want you to get hung up on why is he using R and S or why is he using A. The letters don't matter. You can use any letters you want to. You don't have to use R and S if you don't want to. When I name it, okay, we have to use 2 points that are on that line. And sometimes there may be more than 2, right? We're going to see lines that maybe have 3 or 4 points on it. And then you can use any of the points that fall on that line. But right now I'm going to keep it simple, and those are the only 2 that we have. When we name it, we have a couple of different options here. One way to name it is we could name it line RS. The symbol that we use is a line with an arrow on either end. You got to put an arrow on either end. If you don't, it means something else, and we'll talk about what that is later. But for right now, it's extremely important that we put an arrow on both ends. I could also flip-flop it. I could also call it SR. So it doesn't have to be alphabetical or anything like that. Any order is okay. Any 2 letters. If I threw another letter in here like T, then I could use T to name it. But we only have to use 2 of them. So I could do like TS or TR to name it. And then another way that we sometimes name a line is out here to the side. They're going to put a lowercase letter, and I'm going to use L for a line, okay? But notice there's no point next to the L. It's a lowercase letter that's used to name that line. So I could call it, and in this case, we have to put the word line with it in line L. So there's a couple of different ways that we can name that line. Okay. A plane is a flat surface. So I think of like a piece of paper, okay? This would be considered a plane. Now, this is a little bit outside the box. Just like a line continues on forever, so does a plane. So the best example that I think of, especially since I'm a football coach, is the end zone, right? The goal line is a plane. So does it matter where I cross that goal line at? Do I have to be on the ground? Can I jump over and still get a touchdown? Sure, okay. Can I extend it out over that goal line? Do I have to have my whole body in? No, I just have to break. They call it, if you ever watch a football game, they say you have to break the plane, right? There's like this big invisible plane extended up from the goal line, okay? It goes on forever. No matter how high I jump, no matter where I go, all I have to do is jump over that goal line to score the touchdown, right? So it's like a big invisible plane. It's a flat surface, okay? And a lot of times we think of it as like a piece of paper, okay? This would be a plane. But you could also think of like a wall or a ceiling or a floor as being a plane too. It's a flat surface. When we name this and draw a picture of this, I'm just going to draw a rectangle here, or a four-sided figure. I probably should call it a rectangle. Once again, the letters that we use don't matter. So here I have C, D, E, and F. The order I put them in, the letters I use don't really matter, okay? When I name this, there's a couple different ways to name it. We have to use 3 points to name this plane. And they cannot be on the same line. Okay? And what I mean by that is if I were to put like an R right here, then I can't say CRD because all 3 of those points are on the same line. Okay? But we don't have that issue with my original picture because none of these 3 points are on the same line. C and D are on the same line. D and E are on the same line. EF and CF are all on the same line. But we don't have 3 points all on the same line. Okay? So when I name this, I could call it CDE. I could call it EFC. Order doesn't matter. Which points I use doesn't matter. And all we need is 3. Notice that I didn't use all 4 points when I named it. Okay? What this does is this makes it really hard for me as a teacher to grade, right? Because there is a ton of possibilities here. So if I had a quiz and I said, name this plane, I have to look at it and see if the one you used is correct or not, okay? Not everybody has to have the exact same answer on something like that. There's a lot of different possibilities that you could use here. If you wanted to use all 4 letters, that's still not wrong. You just have to use at least 3. I can't only use 2. 2 is for a line, 2 is for a segment, it's for other things. So I got to use at least 3. Another way that we will see this sometimes is I'll see a P on the inside of that plane. There's no point by it. It's just a letter randomly placed inside of that plane, and that's another way that we could name this. But when I do it, I have to say the word plane P. But it's not a point. I can't say plane F because F is a point. It has to be a letter that's not a point on that plane. Okay? That's the difference. Okay, collinear. So when we talk about vocab, a good way of looking at vocab is breaking it down. Sometimes that makes sense, sometimes that doesn't. Okay? If I look at the word midpoint, midpoint's a word we're going to use a lot this year. The name pretty much tells you everything you need to know. Mid means middle or center. Point means point, right? So it's the point that's in the center of maybe a segment. Collinear, when I see the prefix co, what does that mean? Yeah, it means more than one, right? So an example might be if I have a committee and I choose two people to head up that committee, then I would say that they're co-committee chairs. They're going to head up that committee together, so they're co-leaders of that committee. Okay? Or if we have a team and we have 3 captains, they would be co-captains for that team. Okay? They're all together. So there's a couple of examples of where we might see the prefix co. So collinear means together, linear means line, so together on the same line. And so what we would look at here is, let's say we have 3 points. We would say M, N, and O are collinear. All that means is that M, N, and O are all on the same line. They all fall on that line. I could have more than 3 points. I could add more points to that line, and then we'd have a bunch of points that would be collinear. Right now, it's just those 3. Okay, I'm not going to draw another picture here. I'm just going to draw an arrow down here and use the picture that we did up above. And I'm going to say C, D, E, and F are coplanar. Once again, if we break the word down, co means together, planar means on a plane, so together on the same plane, coplanar. We don't want to use P because P is not a point. P is just a random letter naming that plane. Same thing up here. We wouldn't want to use L when we're saying collinear because L is not a point. R and S are points. L is just a lowercase letter using that to name that line. Okay, so those are some of the basics. Everything in geometry is made up of those basic figures. If you think of like a triangle has 3 points. And then you connect those 3 points together, right? So every figure that we can think of in geometry or in life is made up of those basic concepts of geometry. So now, as we look here, we're going to talk about some of the things that we did up here and name some of these things. Remember, there's more than one way to name some of these, okay? And when I say give 2, that might not be the only 2. It just means we're going to use 2 to name it. So name 2 other names for, and here's how we read this, line PQ. Because we have a line symbol above it, so we read that as line PQ. So PQ is this right here, okay? I know sometimes visually it's hard to kind of visualize what's going on here. So I'm going to kind of do this. What's going on is, let's say the yellow part is a plane, right? And I got a line coming down through that plane. And that's why it's kind of looking like it's coming down. These 2 lines right here, like ST right here, is on that plane. This one is coming down through the plane. So it's coming from a different direction. Okay, so are there any other points on PQ? No. So we can't use any other points. But remember, we could flip-flop it. And we could call it QP. Order doesn't matter. PQ and QP, same thing. Okay, we don't have any other points, but what else do we have next to line? N, right? And so I could say line N. Two other names for plane R. R is not a point. R is just a letter naming that plane, right? There's no point next to it. That's how we know it's not a point. What are some other points that fall on that plane? P is on there, okay. What else? on that yellow surface, on that yellow plane? What are some points that fall on that yellow plane? Yeah.
PVS.
Okay, PVS would be good. That's a good one. Okay, could I also say SVP? Yeah, okay, same thing, okay? And you could write that down. I'm going to name more than two. I could go PVT. If you just want to do two, that's fine. If you want to do a couple more. Now, here's one I'm going to ask you about. Would it be okay if I said SPT? It's not okay. How come? They're on the same line. Okay? So if they're on the same line, we can't use all three on that line. I can do two in another one. So I could use S and P with V, I could use P and T with V, but I can't use S, P, and T altogether because they're on the same line. Okay? And there's no other points on that plane, so those are the 4 points I have to choose from. Okay? I also could do all four if I wanted to. I could say SPTV if you really wanted to do that. And use, you can do more than three, but you can't do less. Okay, questions on that one? Naming the plane. Just make sure you use at least 3 points. Okay, part C, name 3 points that are collinear. 3 points on the same line. SPT. Okay, so we'll go S, P, T. Are there any other options? Do we have three, anywhere else do we have 3 points that are on the same line? No, like here we have Q and P, but there's no point down here on the line. So we only have 2 on this line. N's not a point, okay? V is out here, but V is not on a line. It's just sitting there on the plane, right? So S, P, and T. Hey.
For Adrian Mitchell.
Okay, thank you. Is Adrian here? Okay.
Did you erase that? What'd you actually? Why?
So SPT is our only option there, guys. Okay, that's the only one that works for that. Sometimes there's more than one answer. This time, that's it. Okay, part D, name 4 points that are coplanar. 4 points on the same plane. SPT and V. All 4 of those points fall on that yellow plane, yellow surface. Are there any other points that fall on that yellow surface? No. So there's no other points that we could add to that. Okay. Once again, order doesn't matter. Okay. What the order you list them out in is fine. Okay. I told you the other day, geometry is a little bit thinking outside the box. Sometimes we get questions that are worded a little bit differently that we kind of have to think about in a little bit different fashion. So the question here, first of all, says, which of these statements are true about collinear points? Select all that apply. So when I see something like that, that means all 4 could be true. Maybe only one of them is true, maybe 2 of them, maybe none of them, right? We don't really know. But it could be all 4. So we just got to go through each one and answer yes or no to that. Okay? So what we're looking for, true about collinear points. So when we talk about collinear points, and it doesn't even say how many. Let's start with 2. Because we know we need 2 points to make a line, right? So first question is, a plane contains all of those points. Do those points make a plane? Are they on the same plane? Yeah, because here's what I can do. Right? I could make a plane with it. And then these 2 points are on that same plane. Okay? So that would be yes. Okay? Second one, a line exists that contains all of those points. Well, that's the definition of collinear. Those 2 points are on the same line. So that one's obvious, right? Number 2 is a definite yes. The third one, more than one plane exists that contains all of those points. Okay? This one's kind of hard to think about. But if I were to put 2 points on this flat surface, let's say I put these 2 points right here, and then let's say that I take another piece of paper and I cut through it going this way, does this plane contain the same 2 points? It does, okay? But it's a different plane, right? Hey. Thank you. Okay, so that one's a little bit weird, right? Because we're talking about 2 different planes containing the same line, but that would be like the intersection of those 2. That's where this plane and this plane intersect right here at that line. Okay, what about the fourth one? More than one line exists that contains all the points. Let's say that I were to put 2 points up here. I'm going to connect those 2 points together with one, right? Is there another line that I can draw? A different line that I can draw through those 2 points? Anybody want to try a different line through those 2 points? What do you guys think? Can we do it? Is there any other line that will go through those 2 points? No. I could draw a line through this point, but it doesn't go through that one. I could draw a line through this point, but it doesn't go through that one, right? I could like come in from this direction and go through this point, but it doesn't go through that one. There's no other line I can draw. There's only one line containing 2 specific points, okay? And that's one of the foundations of geometry. So what we said here were the first 3. All worked. Select all that apply. Okay, which statements are true about coplanar points? Let's say these are the 3 points that we have, and we could do more, okay? A plane exists that contains all of those points. True story, okay? We just drew a plane. That plane contains all 3 of those points. Got to have at least 3. Is there a line that exists that contains all of those points? Can I draw one continuous straight line that goes through these 3 points? No, doesn't work, right? Because I would have to change directions to get there, and we don't want to change directions. So it's one continuous line. Is there more than one plane that I can connect those 3 points together? No. If I tried coming in from a different direction or something, then I would be using different points, okay? So there's no other plane that would connect those 3 points together. Maybe 2 of them, but not all 3. Is there more than one line that contains all of those points? No, okay? So on that one, the first one's the only correct one. Okay. We'll call this one more fun with geometry, right? Because this is the foundation of geometry. We're learning everything we need to know about geometry because these are things that we're going to use all year long, okay? So we had the 4 basics. Now we got 3 new ones. Segment, okay? When I think segment, what do I think of? When I hear the word segment, it means a small part, right? It's a piece. It's not going to go on forever. A line extends forever. A segment is a small part of that line. So that's what we're saying here. A segment is part of a line, and it has 2 distinct endpoints. Once again, the letters we use don't really matter. We name it very similar to what we did with the line on the front, except our symbol is a line with no arrows. AB. I could also call it BA. Order does not matter. You don't have to be alphabetical or anything like that. You say AB, I say BA, we're talking about the same thing. Okay? Okay, array. So we have a line that extends forever. We have a segment that has two distinct endpoints. Array is a combination of those two. One side it stops, the other side it keeps going. Okay? So here's what array looks like. We're going to start at an endpoint. We're going to extend it on, going through another point. When we name array, we always start with the endpoint. And I know I'm doing some abbreviating here. With the slash means with, or W with the slash, I should say. Endpoint, just because I'm running out of space, I abbreviated a little bit. So we have to start with the endpoint. So when I name this, I'm going to say DE. One side has no arrow, the other side has an arrow. The point that it goes through is going to be the one that has the arrow. Okay? Now, this is the one that throws some people off. There's another array. What must we start with? The W. Because this is where the array starts. So we have to start at the starting point. So we got to start with W. The reason it throws people off is because they look at this and they just say XW. Well, XW is not correct here. Sometimes we can flip-flop, but on array we have to be specific and we have to start with the endpoint. So we have to call it WX. There's no other name for it. That's it. Okay, finally, this line has 3 points on it. Opposite rays are two rays that start at the same endpoint, but just like the name says, they're going to go opposite directions. So where do you think we have to start here? We have to start at M. Okay, we can't start with N because are there any points to the right of N? We can't start at L because there's no points to the left of L. So we got to start with the point that's in the middle. Okay? And so what we would say here is that MN and ML are opposite rays. It means they're going opposite directions. They start at the same point, go opposite directions through different points. Okay, some examples of those. First of all, common error. I like to talk about common things that are missed, right? Because these are mistakes that are made a lot. And so we have to make sure that we watch out for these common mistakes or common errors. JG and JF have a common endpoint. JG and JF have a common endpoint. Are they opposite rays? They both start at J. So are they opposite? They're not opposite because in order to be an opposite ray, if I say JF, what goes opposite of JF? JE, right? If I said JG, what goes opposite of JG? JH, right? They have to move in opposite direction. So if I start here and move this direction, then I got to start here and go the complete opposite direction. okay? So you can't shoot off in a different angle or a different direction. Okay, so that's a really, really important piece of information. They are not opposite rays. Something you could write down here. J is the intersection but those rays are not opposite. So just because they intersect at a point. And another thing I would point out here too is J labeled with a point? Does it have like a little point there? No, but do we know there to be a point here? Because what happens when two lines cross? Makes a point. Remember in Algebra 1, when we would graph a line, we would graph another line and we had to find the ordered pair because it made a point? You're like, everybody's like, oh my gosh, Algebra 1? You're talking about Algebra 1, Mr. Ruda? We got to go back to Algebra 1? We got to think of Algebra 1 today? We do, okay? It's not going away, guys. So when two lines meet, they make a point, okay? So we got to make sure, even though it's not labeled with a point, we got to know there is a point there. All right, here we go. Give me another name. First of all, how do we read this right here? Okay, except we don't want to use the word line because what do we not have? If it's a line, what's the figure going to do? What does a line do? It goes on forever, right? So this doesn't have any arrows on it. So what are we going to call this? Segment. Yeah, it's going to stop at those 2 points, okay? That's really, really important, okay? Because this means it's going to stop at GH. If it had arrows, it means it's going to continue on through GH. So what would be another name for segment GH? What do you think? Yeah, just flip-flop, right? So GH, I could just reverse the letters, HG, same thing, okay? Would there be any other possibilities? No, because it has to start at G and end at H. Doesn't matter which one you list first, though. Okay, name all the opposite rays of endpoint J. We kind of talked about this a few minutes ago. What's opposite of JF? Okay, be careful of the order though. JE. So if I start at J and go to F, opposite of that would start at J and go to E. Okay? Because it goes in the opposite direction of it. Okay? If I said JG, what would be opposite of JG? JH. Okay? And it's really important that we start with J in all four of those. Because J is my starting point. Okay, what's another name for segment KL? Okay, good. Okay, and if I highlight it, it would be that segment right there. It has to start and end with those two letters. Are KP and PK the same ray? No. Why not? That's right. Okay. They start with a different letter. If this one starts with K, then this one must also start with K. Okay. Rays must start with the same letter. And so we would say no. They need to start with the same letter or point. Okay, are NP and NM the same ray? Do they both start with N? Yep. Okay? Do they both go the same direction? If I start at N and go through N, and I start at N and go through P, it's the same ray, right? All I'm doing is I'm starting at N and just using another point that's on that ray. Okay? And so we would say yes. Both start at N and they go the same direction. Hey, we've kind of talked about this throughout the day today. When two lines meet, if I were to draw you a picture of two lines meeting, where do those two lines meet at?
Right, intersect the middle.
Okay, and what would we call that middle? Okay, and what would we call that center?
Point A.
A point. Yeah, they meet at a point. Couple minutes ago, we talked about algebra 1, right? When I drew two things up on the coordinate plane, and we said, okay, where do those two lines cross at? Where did they cross? They crossed at a point. Remember, we had to identify the ordered pair where they crossed at? That was algebra 1, right? We're doing essentially the same thing in geometry. When two lines cross, they cross at a point. Okay? And maybe I could call that like point P. That's where the two meet. Okay, if I said this wall right here and the ceiling meet, where would the intersection be? It'd be an edge, right? But what would we call that edge? Is it just a single point? Or does it go on longer? Right? It would be the whole thing right there. Now, here's what you have to think about. We're going to say that here it's a line, because if it's a plane that goes on forever, it's also going to be a line that goes on forever. I know here we have a stopping point because it's a wall, but they meet at a line. Okay? Same thing we talked about earlier. If I take two pieces of paper and they intersect right here, a line is where those two would meet. Okay. Which of these sketches shows two different lines that intersect a plane at the same point? So here's two different lines. Do they intersect plane P at the same point? No, so that one's out. Okay, do these two lines intersect at the same point? Yep. Okay, and it could be more than one. So let's see if the other ones work. Okay, is this a line right here? What would we call this? It's a ray, yeah, because it starts. So this is not necessarily a line. Okay, if this one continued on, then it would be a line, and then they would intersect at point A. So it's kind of like, you know, vocabulary, or it's a little bit tricky, right? Because they do intersect at A, but one's a ray and one's a line. How many lines does the last picture have? One. I need two lines, right? Right now I only have one. So I would need another line to show that they intersect. Okay, next one. Identify two planes that do not intersect. The last one, okay? It means they do not touch one another at all. You got like a piece of paper here, you got a piece of paper here. They're parallel to one another, so we call those parallel planes because those two planes would never cross or touch one another. Every other picture, they're intersecting. Whenever you see little dotted lines like this, that it's like showing you, like, I can't see that point of view, right? Like if I showed you a Kleenex box and I held the Kleenex box like this, can I see this back edge, the point of view I'm showing you? No, do we know it's there? Yeah, right? We just can't see it from your point of view. We know it's there. So they're gonna put like a dashed line because it's there, but we just can't see it from that point of view. So whenever you see that little dashed or dotted line, That's what it's showing you. That's what it's talking about. Okay, name the intersection of line PQ and line K. Here's line PQ. Here's line K. Where do two lines meet? At a point. Okay, and what point do these two lines meet? M. Okay. And you can say point M or you can just say M, because if it's an uppercase letter, we know we're talking about a point. Okay? And we only have one. Where do plane A and plane B intersect? Line K. Good. Okay. And that would be the only way to name it. You might look at it and you might say, well, there's an M here, but do I have any other points on this line? No. So I would need a point somewhere else on here to name it with the 2 points. Right now there's only 1 point, so I can't use a point to name it. Here's the lowercase letter K. K is representing this line right here, line K. Okay. Where do line K and plane A intersect?
Plan B.
What'd you say?
Plan B.
Not quite. If I were to take a plane, let's say this is plane A, and let's say I lay a line right on top of it, where do those two intersect at? Line K. Yeah, it's the line. It's a little bit weird, a little bit different. Line K is laying on that plane. All right, we're getting close on time. We have a couple left to finish. On Monday, we'll finish the notes. We have kind of an activity that we're going to do, and then I'll give you some time to work on your first homework assignment. Okay? Have a great weekend, and we'll see you on Monday.